No equipment is perfect. Some equipment can measure very precisely, but most has some error. People aren't perfect either. Sometimes they misjudge, and other things can affect the accuracy or precision of your measurement as well. There are two main types of error: random error and systematic error. Systematic error is, well, systematic. It happens every time you make a certain measurement. Measurements are consistently higher or lower than they should be. If you repeat the same experiment with the same equipment, you'll get the same error. Examples include calibration error. This happens a lot with scales. They need to be calibrated in order to mass things effectively. Worn-out instruments or ones that have defects can cause systematic error and skew your results. Taking measurements incorrectly can also cause systematic error if you're making the same kind of mistake over and over again. Systematic error affects accuracy. In this example, we can see that there's systematic error because all of the points are to the left, clustered together. These measurements are precise, but they're far from the center of the target, which means they're not accurate. Random errors are errors that can't be predicted. Errors of judgment in reading a meter or scale. The number said 5, but I wasn't wearing my glasses, so I read it as 2. Fluctuating experimental conditions. Hot one day, cold the next. That could cause random fluctuation. Or if the wind keeps blowing over my solar cooker. Those are all things that can't be predicted. Random error affects precision. In this example, we can see that although the points surround the center of the target and are more or less distributed about the center, they're very far from each other. They are not very precise. Now let's look at some examples. Example 1. I use a 1-quart milk carton to measure a 1-liter sample of milk. Well, this would result in a systematic error. The volume would always be too small because a quart is slightly smaller than a liter. Let's try this one. I use a balance that is sensitive to 0.1 gram to obtain 0.251 grams of vitamin C. This will be a random error because the balance is not sensitive enough to pick up milligrams. 1 milligram is 1,000th of a gram. My measurement's likely to be randomly either too high or too low. I accidentally read the thermometer as 29 degrees instead of 39 degrees. This would be random error, because if I read it again, I might have read it right. Okay, last one. I mass several samples of chemicals, but I forget to tare the scale. Now, mass, in everyday speech, we'd call that weighing, but since we're looking for the mass, that's what we call it in chemistry. And tearing a scale basically means setting it to 0. So, if I forget to tare the scale, then I am likely to get systematic error because all of my measurements are going to be skewed in the same direction. What direction it is depends on what the reading of the scale was before I started putting stuff on it. You should now be able to explain the difference between systematic and random error.